In the universe, there are some supergiant stars that make the sun look like a piece of dust. In 2024, scientists discovered a supergiant star. Its size is large enough to swallow the sun and half the solar system. In the night sky, the largest star besides the sun is not a North Pole star, but a Betelgeuse star in the same constellation. This star can only be observed from the southern hemisphere of the Earth. In 2024, scientists successfully observed the surface of this star in detail for the first time. Its image is really not disappointing. They found that the surface of the Betelgeuse star was as hot as fire, and it was boiling to form a huge antiparticle bubble. And the volume of these bubbles can actually match our sun. Although Betelgeuse is the largest star in the night sky, there is still a big gap between it and the largest star in the universe. Until recently, the name of the largest star in the universe still belonged to the Betelgeuse star. In 2012, astronomers measured the three giant stars in the middle of the Milky Way. Among them, the Betelgeuse star's radius was shocked by another scientist, 1780 times that of the sun. But don't think that this star is only 1780 times the radius of the sun. The actual situation is more complicated. To explain this truth, imagine that you have two particles in front of you. The radius of a white particle is equal to the radius of a sun, and the radius of another gray particle is twice that of the previous one. Although the radius of a gray particle is only twice that of a white particle, its internal volume can accommodate 8 white particles. The same principle also applies to 3 celestial bodies, such as a star. That is to say, the volume of the Betelgeuse star can accommodate nearly 5 billion suns. However, a new measurement in 2023 showed that the previous calculation of astronomers was wrong. The radius of the Betelgeuse star is actually only 900 times that of the sun. So, in 2024, the largest star in the universe was transferred to the head of the WG64 star. This giant star's radius is more than 1,120 times that of the sun. It is located in the Milky Way, 60,000 light-years away from the Earth. Fortunately, this giant star is very far away from us. Otherwise, if it is placed in the center of the solar system, it will swallow 5 planets, including Jupiter. The WG64 star is also surrounded by a huge gas and dust cloud blown by a strong horizon. The quality of this dust cloud is 9 times that of the sun. Its diameter extends to 1 light-year. Therefore, the WG64 star is undoubtedly the largest star in the universe. However, it's not that simple. There is another star larger than WG64, but it is often overlooked by scientists. It is the DFK-1 star. The radius of this giant star is about 2,150 times that of the sun. But because it violated the so-called zero line twice in physics, it was not widely recognized. The zero line describes the condition of maintaining the water pressure balance within the star. It is a subtle balance between the internal absorption of gravity and the external push of gas pressure. This balance determines the quality of a star, the radius, and the surface temperature. However, the DFK-1 star has broken the theoretical limit on radius and temperature. According to the theory, the surface temperature of a supergiant star should not be lower than 3,500 Kelvin. But the temperature of the DFK-1 star is only 3,200 Kelvin, which is lower than that of the coldest supergiant star. This suggests that there may be errors in the measurement of the DFK-1 star. Perhaps our understanding of the law of gravity and physics is still not perfect. Therefore, the WG64 star is still considered to be the largest star in the universe. However, the star's ranking is not just the size of the competition. Astronomers will also classify the stars according to their luminosity, just like the Guinness Book of World Records. The champion is not necessarily won by a single indicator. For example, the 2136A star, although the radius is only 42 times that of the sun, it has reached its limit in terms of quality, brightness, and surface temperature. The 2136A star's quality is almost 200 times that of the sun. It is the second largest star in the universe, only second to its neighbor in the Spider Galaxy. Its quality is 9,998 star, which is 230 times that of the sun. However, there are also shortcomings in supermassive stars. The 2136A star's wind is extremely strong, and its speed reaches 2,600 kilometers per second. It will lose about 30 billion kilograms per second. Scientists estimate that since its formation, it has lost about 35 sun qualities. Its luminosity is even more amazing, about 477,700 times that of the sun. If the sun is so bright, the Earth's surface temperature will rise to 16,200 Kelvin, which is 3 times that of the sun's surface temperature. But even so, the ranking of the 2136A star in terms of brightness is only the 7th in the universe. And the brightest star is the Gossamer, which is located in the solar system. Its brightness is 2.55 billion times higher than that of the Sun. In terms of temperature, although the surface temperature of the 2136A star is 46,000 Kelvin, which is about 8 times higher than that of the Sun, it still cannot compare with the truly hot star W2-102 in the universe. The radius of W2-102 is half of the Sun, but it has extreme horizon wind and strong ultraviolet radiation. The surface temperature of the star is up to 200,000 Kelvin, which is about 36 times that of the Sun's surface temperature. Scientists speculate that W2-102 is close to the end of life, and it may soon explode in the form of a supernova. In the record of stars, there are not only the 5 largest but also the smallest members. The Apogee 055557 star is the smallest star. Its radius and mass are only 8% of the Sun, even smaller than Jupiter. However, although Jupiter's mass is twice the mass of all other stars, it is only 1/1000th of the mass of the Sun, far enough to trigger nuclear fusion, so it cannot be called a star. In addition, there is a unique star in the universe, Pluton. The PSRB 0943 star may be one of the most amazing stars. This neutron star not only has a super strong magnetic field, but also rotates at a speed of 1.14 per second. Although its radius is only 2.6 kilometers, which is equivalent to 1/4 of the Sun, it emits a strong radiation that can destroy the life of the Earth. In addition to these extreme records, there is also a cosmic mystery, the supernova IPTR-14 HLS in the Big Meteor. In 2014, a scientist from the Barber branch of the University of California discovered its explosion. But the strange thing is, this star has 5 consecutive explosions in the next 1,000 days. Each brightness is equivalent to the formation of 5 new stars. And what is more shocking is that scientists found in historical data that it had exploded 60 years ago. Scientists speculate that the antiparticle core may produce antimatter. Every time antimatter comes into contact with normal matter, it will be extinguished, causing a similar supernova explosion. There are also some theories that there may be not only compressed nuclei in some red giant cores, but also complete neutron stars hidden. Such a big star may be formed under certain circumstances, such as when 2 celestial bodies collide in a congested star system like a spherical star group. This hypothesis about the existence of a supernova was first made in 1977. Based on theoretical physicist Soren and the celestial physicist Hannah Chitoba proposed. After a long search in Chile, they found the first existing Soren-Chitoba celestial body, which is a star called HV 2112. However, 4 years later, a new study denied the possibility of neutron stars in this red giant star. The problem is that this celestial body should contain high concentrations of aluminum, wood, and aluminum. However, when scientists re-examined this candidate celestial body, they did not detect the concentration of these necessary elements. However, there is no need to be discouraged. In the same year, scientists discovered a new candidate celestial body, the first in the universe, HV 11417. If this discovery is finally confirmed, then the record of the universe will fall on the starry night. And in the record of the universe, it may not only be the star of Damocles alone. In 2023, James found several potential dark matter star candidate celestial bodies. These celestial bodies are extremely far away from us, so that the light we see now was actually emitted nearly 13.8 billion years ago, that is, after the explosion of the universe just 200,000 years later. If scientists can prove that these celestial bodies are not distant stars, but real stars, it will be a scientific breakthrough for thousands of years. After all, the existence of dark matter itself is still a theory that has not been proven. According to the theory, dark matter stars may be the early stars in the center of the universe, formed by the gas and gas clouds of exploration. The dark matter particles inside these stars also show antimatter properties. The collision and annihilation between the particles will also cause another reaction in the gas cloud. These processes cause the gas and gas clouds to heat up, and thus the star is born. In theory, the temperature of a dark matter star can reach the level of the Sun, but the quality is 1,000,000 times that of the Sun, and the brightness is 100 times that of the Sun. When life ends, this kind of star may be corrupted into a black hole that exceeds the quality. Now, scientists only need to find the last key clue in the electromagnetic waves, such as a specific isotope. This will prove that these celestial bodies are indeed dark matter stars, not stars. However, when the scientific community is eager to break through, another new record holder may be born in the universe, the dark matter star. The dark matter star represents the final evolution stage of a star like the Sun. The reason why the dark matter star has not yet appeared is because the lifespan of the universe is still too short. When the nuclear reaction of the Sun's core is completely stopped, and the outer material is ejected to form a star, the rest will be a white matter star. This kind of star is extremely dense, and the surface temperature is between 400 to 150,000 degrees Celsius. However, Due to the death of the inner part of the star, it cannot continue to maintain the temperature, so the sun's remnant sea will gradually cool down and eventually become a black matter star, a cold, dense, and dark celestial body. But this transformation takes about 10 million years, and our universe was only born about 13.8 billion years ago, so the dark matter star does not exist yet. However, in the distant future, these dark matter stars may become powerful competitors in many universe records. In addition to their extreme density, this density may even cause an explosion, and some high-quality dark matter stars will become supernovae. They may also refresh the records with their extremely low surface temperature. In theory, their temperature may be close to absolute zero. However, this low-temperature record has never appeared in the universe. So, among the many strange stars, which one is the most worthy star in the universe? The answer may not be far away. In fact, this is the Sun, which is the most familiar star in the sky that we look up at every day. Although the Sun is not the largest and brightest celestial body, it is the only star that has ever given birth to life.